Next learning outcome in 6.1R, state the characteristics of a system in equilibrium and interpret the curve of concentration reactants and products against time for a reversible reaction. The characteristics of a system in equilibrium. The first characteristic is the equilibrium can only occur in a closed system. So what is a closed system? A closed system is a system to which nothing is added or removed. For example, in closed system, oxygen gas in the air cannot enter or leave the system. The second characteristic is the concentrations of reactant and product are constant over time. It is related to the third characteristic where the rate of forward is equal to the rate of reverse because the reaction rate depends on concentration. Actually, the rate of forward reaction decreases as the concentration of reactant decreases, while the rate of the reverse reaction increases as the concentration of product increases. But in equilibrium, the rate of forward is equal to the rate of reverse because the concentration of reactant and product are constant. The fourth characteristic is the reaction quotient Q is equal to the equilibrium constant K. What is the difference between Q and K? Now consider this equilibrium system. Q is the quotient of activities of products and reactants at any stage of a reaction. So, the value can be here before the equilibrium or even here after the equilibrium for NO2. But K is the constant of a certain reaction when it is in equilibrium. So, the K is the value when the system has reached equilibrium. Here or here. So, if the value of Q is not equal to K, means the system is not in equilibrium. While if the value of Q is equal to K, means the system is in equilibrium. Next, to interpret the curve of concentration reactant and products against time for a reversible reaction, we refer the change in the concentration of N2O4 and NO2 with time in two experiments. Consider the dissociation of 1 mole of N2O4 into 2 mole of NO2. In figure A shows the dissociation of N2O4 with initial concentration 1 mole per dm cube to NO2, while figure B shows the reverse reaction that is starting with NO2 of concentration 2 mole per dm cube. Whether the reaction starts with 1 mole of N2O4 or 2 moles of NO2, the same concentration of the two compounds result once equilibrium is reached. So for both reactions, the equilibrium concentration of N2O4 are 0.8 mole per dm cube here, while for the concentration of NO2 are 0.4 mole per dm cube. That means whether starting from pure N2O4 or from pure NO2, the system will always reach an equilibrium mixture of N2O4 and NO2. Exercise. State the characteristics of a system in equilibrium. So please answer this question to achieve the learning outcomes of this subtopic.